Alrighty, y'all, welcome back to another tutorial, and in this one, we are going to be talking about gas. Now, I would like to start things out by telling you a story, and that is the story of whenever I first started developing on the Ethereum network. So this is me right here. This is back in the days when I was gray and I had no face. So either way, I opened my laptop and learned some Ethereum, decided to connect to one of these nodes. And I'm like, okay, I know how this works. I'm just going to write a smart contract. I'm going to deploy it to the network. And then let me just tell this node, hey, can you go ahead and run this? And the node responded to me, and cannot run. I need gas. And I'm like, okay, well, I got gas. Then the node was like, not that kind of gas, talking about Ethereum gas. And I'm like, okay, this is weird. So you're telling me that in order to run this, that you need something called gas, and with gas, you will then be able to process these transactions. And it's like, yep. And then I'm like, wait a minute, am I talking to an Ethereum node right now? What's going on? So either way, I decided to do a little bit more research online. So the very first thing that I learned is that when measuring gas, it's typically measured in gwei rather than wei or ether. And just as a reminder, 1 gwei is equal to 1 billion wei. So back to this gas situation here. Now, I know at the beginning of the tutorial, what I said is that in simple terms, gas is really just the fee required to send transactions on the Ethereum network. Now, more technically, gas is the unit that allows us to measure the amount of work required to execute some code on the Ethereum network. All right, so what the heck do I mean by that? What I mean is this. Whenever you are trying to execute some, let's say, smart contract on the Ethereum network, not all smart contracts require the same amount of work and energy from these nodes. For example, let's say that you had a very simple smart contract and all it did was like add 2 numbers together. Maybe that would take, let's say, 1 gas. Now, let's say you had another smart contract and you're making this, your own multi-sig wallet with NFTs and I don't know, whatever you want to put in a smart contract. But it took a long time to actually process all this logic. So in that case, maybe that smart contract would require 3 gas. So we see somehow that the complexity and the amount of effort and energy it takes to run these smart contracts is somehow related to the quantity of gas that we need. However, we still didn't talk about what the heck gas is. And on top of that, how the heck do we even calculate how much gas is required to run these smart contracts? So it turns out that in Ethereum, every single operation that gets ran on a smart contract, basically anything that you can do in a smart contract, has a related cost. Now, I'm sure the URL might change over time, but if you type in something like opcodes for the EVM or opcodes for Ethereum, you're going to find a list of the current prices. And let me scroll down and show you what's going on here. So we'll get to the details of this in a minute, but just check this out for the time being. So the name is essentially the name of these operations, and gas, this column right here, is essentially the gas cost of these operations. All right, so let's figure out what the heck this means. Like add 3 gas, multiply, that looks like it takes 5 gas. So what does this all mean? So what this means is that later on, whenever we start actually writing smart contracts, and by that I mean actually writing the code for them, typing on our keyboard, every single operation that we can include in our code, it has a cost. For example, whenever we have 2 numbers and we want to just add those together, it's going to require 3 gas. So this is just example code that we're going to see in our smart contract. This is the name of the operation, and this is the related gas cost. So again, that translates to this name and this gas cost over here. And just another example, just so we had 2 different ones. For multiplication, this is what it's going to look like in our actual source code. And of course, this operation, this little asterisk right here, if you're familiar with programming, then that means multiplication. And the cost for this is 5 gas. All right, so this is starting to make sense. The more complex your smart contract is, the more operations it has, and each operation is going to require more gas. But now we still have the question of, well, what is the price of each one of these gas? I mean, is it 1 gwei? Is it 100 gwei? So we know that if we had a contract with just these two operations in it, for example, that it would require a total of 8 gas, but is that like a fraction of an ether? Is that like 20 ether? Like, what is that? So check this out. Unlike purchasing something in real life that already has a price tag stuck to it, in the Ethereum network, users actually specify their own gas price when sending transactions. Now, this price that they specify, it represents the price per unit of gas that the user is willing to pay. Now, miners can choose whether it's worth it for them to accept this transaction. So in this sense, try to think of gas not so much as something with a fixed price, but more like a bidding system. Now, sticking with our gas theme, it's kind of the equivalent of going to a gas station and saying, I'll offer you 5 cents a gallon for this gas. In that case, the gas station owner is just gonna pretty much ignore you or laugh at you. Now, if you go to the same gas station and say, I'll offer you $28 per gallon of gas, then the gas station owner is gonna, even if they're serving a customer, they're gonna push them out of the way. Okay, whatever you need. So that is pretty much what's going on in the Ethereum network, where people are essentially going to bid to get their transactions processed, and the miners are pretty much going to prioritize those by who's ever bidding the highest amount. Now, the average price of gas is actually determined by the overall demand for the network resources. And a very cool resource that I use quite often is etherscan.io/gas tracker. If ever you just want to know the current price of gas, then you can go here and it'll tell you right now it's hovering right around 145 gwei. Oh, hopped up to 162. Look at that. Now, in addition to gas price, we also need to talk about gas limit. So whenever you send a transaction on the Ethereum network, what you're going to do is you're going to both specify the gas price, which we just talked about, and this field called gas limit. So gas limit is the maximum units of gas that you're willing to spend on the transaction. Now, another thing that I want to mention is that when executing a transaction, nodes are going to keep track of the gas being used compared to the total amount of gas that you said is allowed. So if execution cost ever exceeds the amount that you specified is basically the maximum amount allowed, then execution is just going to stop. In other words, the nodes are just going to stop processing that transaction. Now, there's another thing that I want to point out, and this is something that may confuse you if you're looking at examples of, calculating this online, and that is there was something called a London upgrade in the Ethereum network, and as part of this upgrade, it actually changed the way that these gas fees are calculated. So I just want to point this out. We're going to be taking a look at how they were calculated pre-London and also post-London. But again, I want to mention this because if you're looking, maybe you forgot this video and you want to go back and look for a reference of how these things are calculated. If you're seeing two different formulas and your head's blown up about why is there two different formulas, it's likely because one was pre-London and one was post-London. So anyways, let's get into this example. And again, this one right here, we are covering pre-London. However, it's useful to cover anyway. So the max gas fee, in other words, the maximum amount you're willing to pay for the entire transaction is equal to the price of gas. Again, this is something that you specified. How much do you think is needed to more or less convince that gas station operator? And then the gas limit is how many of these gas units you're willing to spend. So just to hammer this down, we will say that if you set a gas price of 100 gwei and you specified a gas limit of 8 units of gas, then this would equal a maximum gas fee of 800 gwei. Now, I say maximum rather than just the, hard-coded gas fee, because if this transaction, let's say that you specified it for this actually, let's say that a node was processing this transaction, and after running the entire logic in the smart contract, it realized that, it actually only costs 600 gwei. That 200 additional gwei is not just something that you overpay. It's actually returned to you as the user. So again, just want to hammer down, this is the maximum gas fee for the transaction, but it's often higher than the actual gas fee. Now, starting with the London network upgrade, every block has a base fee, and this base fee is the minimum price per unit of gas for inclusion in the block. And this base fee, by the way, it's automatically calculated by the network. It's not something that the user specifies themselves. So whenever you see base fee, you can just think the minimum gas price. And by the way, another fun fact is that whenever a block is mined, this base fee is actually burned. In other words, this amount of ether is actually removed from circulation. So with this base fee, there's actually no more of going to that gas station in air quotes and saying, I'm going to offer you 5 cents a gallon, since there's always a fair minimum gas price. Now, on top of the base fee, users are also expected to set a tip, and you may often see this as priority fee sometimes, but whether you call it a tip or a priority fee, it's the same thing. So what is this tip? Well, if you go online, it's going to say that the tip compensates miners for executing and propagating user transactions in blocks and is expected to be set automatically by most wallets. Now, what that means is pretty much just a bribe to miners. In other words, miners are going to prioritize the transactions with the highest priority fees, or in other words, bribes, ahead of all the other ones. And they're going to do this because this fee right here, remember, this doesn't go to the miners. This actually gets burnt, or this ether is removed from circulation. So the miners are going to be able to keep this tip right here. So of course, what they're going to do is as transactions come in, they're pretty much going to sort them by highest tip to lowest. And the ones who bribe the miners the most pretty much get their transactions processed faster than the others. Now, to calculate the total transaction fee, you take both of these and you add them together, and then you multiply it by the gas limit. Now, this gas limit is just identical to before. It's just a limit that the user sets. So again, just to wrap everything together, total transaction fee is equal to the sum of the base fee plus the tip multiplied by the gas limit. Now, the last thing that I want to cover is this idea of max fee per gas. So what the heck is this max fee per gas? Because I mean, things couldn't get any more complicated, right? Well, check it out. It's actually not that bad, and it makes a lot of sense once you learn about it. So max fee per gas is the absolute maximum that you're willing to pay per unit of gas to get your transaction included in a block. Now, under most circumstances, the actual fee that you end up paying is actually going to be less than the max fee per gas. All right, so it seems like this system was working all right before, so why would we ever want to include a max fee per gas? So imagine this scenario. Imagine that you sent a transaction up to the network and the current base fee was, we'll just say one way. So you added one way here, maybe you added whatever for a tip, and you send it up. Now, immediately after sending that transaction to the network, what the network did is it recalculated the base fee, so it's now two-way. So now you have a transaction up there floating around the network, which is pretty much incorrectly funded. So what's going to happen to it? I mean, is it going to get dropped, or is it going to fail, or is it going to become stuck? Is the base fee going to go back down and then it gets processed? I mean, there's a lot of unpredictability here. So that is why this max fee per gas was introduced. So essentially, for a more predictable transaction settlement, it's typically considered best practice to set a max fee to pretty much anticipate the possibility of an increasing base fee. Now, just like in the last example, the difference between the max fee per gas and the actual fee is refunded back to the user. So the user doesn't need to worry about overpaying beyond the base fee whenever their transactions are executed. So just to break this down, by max fee per gas, it's pretty much saying this is the maximum I'm willing to pay. Now, the actual fee is what you end up paying, and it's usually less than this. So the refund amount is basically pretty simple math. The maximum you are willing to pay minus the actual fee, and that's the amount that gets refunded back to the user. And on that note, I believe that's all we need to cover on the topic of gas and fees. And by all we mean to cover, kind of laughing when I say that because I know I just dumped a ton of information in all your heads. But yeah, I think that covers gas and fees. So thank you for watching. Don't forget to subscribe, and I will see y'all later.